Hello my dear students. Today we are going to discuss a very important question that can be asked in the 5 mark section, from the chapter Determinants. That is, it is a sure question, So the question is, we have to solve the system of equations using matrix method, This is a set of linear equations. We have to solve this equation. There are some procedures. One by one we can look, So first we should represent like this, Ax equal to B. Here in the system of linear equation, here we can represent A as a matrix using its coefficient of this equation, 2, 3, 3 as first row. 2, 3, 3 as first row of the matrix A. Similarly, second we have 1, minus 2, 1. So 1, minus 2, 1. For third we have 3, minus 1, minus 2. This is A. Then x is what all variables, that is x, y, z. In this system of equation there is x, y, z other. Then B can be represented as this term, that is 5, minus 4, 3. So the first step is writing the system of equation in this form, Ax equal to B. Now next step is we need to find determinant of A. For this matrix we need to find the determinant and we need to check whether it is not equal to 0. If it is not equal to 0 means determinant is known as non-singular. If this answer is not equal to 0 means this matrix is non-singular. If it is non-singular, it means A inverse exists. This is a point you should remember, That is, we should first find this determinant A. If it is not equal to 0, it is known as non-singular matrix. If it is non-singular, that means there exists an A inverse. Then we can write this section as x equal to A inverse B. So what is a singular matrix? Its determinant will be 0, just reverse. If it is not equal to 0, it is non-singular matrix. So these points clear? Then we are going to find out the determinant A. So students, we are going to find the determinant. You have already know how to expand row wise. So just directly I will write. We are expanding along first row. So first element 2 into its corresponding row and column, just hide, and minus 2 it is 4, minus it will become plus 1. Correct. Alternatively the sign will change. So the next element is what? We have 3. Its sign will change as negative 3 and its corresponding row and column just hide. Then these 4 elements, that is minus 2 into 1, that is minus 2. Here 3 minus 1, 3 into 1, that is minus 3. Then last element is again 3. It's here minus, so plus 3. So its corresponding row and column just hide. Then minus 1 into 1 we have minus 1. Here there is 3 into 2 we have 6, minus 6, minus plus 6. Then just to simplify it as, here we have 2 into 4 plus 1, it's 5. Then here minus 3 is the, here minus 5. Here plus 3 is the, inside we have 6 minus 1, it's again 5. Then last we have 2 into 5, it's 10. Minus it's plus 15. Here we have again plus 15. So 15 plus 15 is 30. 30 plus 10 is 40 is the determinant, which is not equal to 0. Therefore you have to write A inverse exists. So the second step completed. We have find out that A inverse exists. How? You can write if it has a point, that is determinant A is not equal to 0. Therefore it is a non-singular matrix and A inverse exists. You can write it as a 1 point while solving this question, So move on to next step, how to find A inverse. Okay. So students, formula for finding A inverse, just you need to keep in mind, there is no proof for that. Okay. So A inverse, to find the formula is 1 by determinant A into adjoint of A. Okay, this is a formula you should keep in mind in order to find A inverse. Determinant A we have already find out, that is we got 40. Okay, next we need to find what? This adjoint A. That I will tell how to find out this adjoint A of that matrix. Okay, students, this is the determinant. We have to find adjoint of A. Okay, correct. For A inverse we have the formula 1 by determinant A into adjoint A. So this adjoint A is just the transpose of cofactors. So first we should find cofactors. What is cofactors? Okay, that is cofactors means nothing. Each element I am going to find out the cofactors for each element. Okay, I will denote the first element cofactor as A11. That is just as expanding the determinant. There is nothing new. We will hide its corresponding row and column, and just we will take this small matrix. Okay, that is -2, 1, -1, -2. Here first A11, there will be a negative 1 into 1 plus 1. That is just to memorize. For even numbers it will be plus, and for odd numbers it will be just put a negative sign. Here 1 plus 1 is 2. It's an even number, so it will be plus this determinant. Okay. So on adding 2 into 2 it's 4. Minus it will become plus 1, that is 5 is the first cofactor of this element 2, that is A11. This is called the cofactor. For each element we need to find this cofactors, and taking the transpose of those cofactors it is called adjoint. On solving it will be more clear. Okay. So we can find for each element the cofactors. We have find out for A11. Similarly for A12, that is for the element 3. For element 3, just hide its corresponding row and column. Then we will get 1, here 3, then we have -2. Correct. Here 1 plus 2 it's adding, we are getting 3, which is an odd number, so put a negative sign outside the determinant. So we have negative into 2 into 1, negative sign is there, so -2, then -3 into 1. That is we have negative, here -5, negative, we will get +5, which is A12. Then for next element we are going to find out for 3. That is, it is A13, correct? 1 plus 3 it's 4, so it is an even number. Put a plus. Then hide its corresponding row and column, this determinant. Okay. 1, -2, 3, -1. Then it is -1, minus plus we have 6, that is 6 minus 1, we have again 5. Clear? Then for next row element, first row elements we have completed. Then for next row element. Okay. So next row we have A21. A21 means it's again 2 plus 1, negative sign will come. It's an odd number. Okay. So its corresponding row and column just hide. We have 3, 3, -1. We have -2. Okay. So on solving this we have negative. This is -6. Minus, already there is a negative sign outside, so that you put first, otherwise you will miss the negative sign. Okay, first you put this negative outside, then 2 into it's 6, correct? -6 minus plus we will get 3, that is we have minus of -3, it will become +3, correct? Okay. So students, this is the cofactors of this determinant. Each you have to find for every element. Okay. Then just write it as a matrix, that is 5, 5, 5. The next row elements is 3, minus 13, 11. The next row 9, 1, that is minus 7. So taking the transpose of this matrix, we will get what? Adjoint A, correct. So on taking the transpose, we get, that is 5, we are writing it as a column. This row is writing it as again column. Negative 30, 11, 9, 1, minus 7. So this is called the adjoint of A. Okay, now we can find A inverse. How? Just to substitute in that formula. That is, A inverse is actually 1 by determinant A, we have already got it as 40, into we have adjoint A, this matrix. Okay, that is 5, 3, 9, 5, minus 13, 1, 5, 11, minus 7. Okay, so this is the adjoint A. We have now got A inverse. Now what? We have to substitute in the earlier equation. That is, solving equation is x equal to A inverse B. Here you can substitute here A inverse. So directly you can write otherwise 1 by 40 into this is A inverse 5, 3, 9. Then 5 minus 13, 1. 5, 11, minus 7. Here B is what? That was the that side matrix. That is, in this linear set of equations we have it as 5, minus 4 and 3. Okay. This is B section. So now this is x equal to the form of A inverse B. X equal to, this is A inverse, this is B. It is now in the form of this. Now you need to simplify this to matrix. That is, just multiply these matrices and divide it by 40. So here we are going to multiply these two matrices. So 1 by 40 you keep it there itself. Okay. So 5 into 5 we have 25. Here 3 into 4 it's minus 12. Then 9 into 3 it's plus 27. Then next row. 5 into 5 again it's 25. It's 13, 4, it's 52, correct. 12, 1, it's 52. It's minus plus 52 will come. Then last we have 1 into 3, it's plus 3. Then again here 5 into 5, it's 25. 11 into 4, it's negative sign will come, negative 44. Then here also negative 21 will come. Okay, now we need to simplify this. Okay, so after simplifying, what you will get? Simplifying this, 25 minus 12 plus 27, it comes 40. Then adding these 3, 25 plus 52 plus 3, it's 80. 25 minus 44 minus 21, it's minus 40. Okay, then we have a 1 by 40. Then now you can divide each term by 40. So 40 by 40, it's 1. 80 by 40, it's 2. Then again 40 by 40, it's negative sign is there, so negative 1. So this is actually the value of x, y, z. Okay, clear? So the last final answer you can write it as the solution for this x, y and z. That is, x is 1, y is 2, then z is minus 1. This is the answer, solution of the system of linear equation. Clear? I think it's little bit lengthy. You should keep the steps. First you should find the determinant A, then A inverse, then adjoint A. Some steps are there. So keep in mind and practice. Okay. So see you soon. Bye.